Okay, in this video, we're going to look at what we call the test for increasing and decreasing in functions, And what this is going to do is basically connect this concept of increasing and decreasing to calculus. So, let's say you have a function which is increasing. So this function is increasing. What does that tell me about the slopes of the tangents? Well, you should be able to see from the diagram that if the function is increasing, then the slope of the tangent at every point on that interval will be positive. Right? So all these slopes have positive, or all these tangents have positive slopes. Whereas if a function is decreasing, then the slope of the tangent is negative. So how does that connect to calculus? Well, we know that the slope of the tangent at any point is equal to the first derivative. So if it's increasing and has positive slope, or the tangents have positive slope, then that tells me that the first derivative will be a positive number. And then if it's decreasing and the tangents have negative slope, that tells me the first derivative will be a negative number, less than 0. So that's basically what our test is. So the test for increasing and decreasing functions just says exactly this. If the first derivative is positive for all x in the interval I, then f at x is increasing on that interval I. So positive first derivative, increasing. If f prime at x is less than 0, or negative, then for all x in I, then f at x is a decreasing function on that interval I. Okay? So one thing to note, though, is that this test doesn't tell you what to do when the derivative is actually equal to 0. So if it's bigger than 0, it's increasing. Less than 0, it's decreasing. If it's equal to 0, this test doesn't tell us what to do with that point. It doesn't tell us, should it be in the interval of increase? Should it be in the interval of decrease? Should it be in neither? And we saw an example, like, remember that example, x squared. If f at x equals x squared, then the first derivative is equal to 2x, and you can set that equal to 0. So x equals 0 is kind of the point where the first derivative changes from positive to negative. And f prime at x is less than 0 if, so when is this less than 0? Well, whenever 2x is less than 0. So if x is less than 0 and f prime at x is less than 0 if x is bigger than 0. And this this would be your decreasing interval. And this would be your increasing interval. But if you remember from the other example, we actually included the point 0. We said 0 should be included in both the interval of increase and decrease. So when we use this test, it tends not to give, or it won't give us that sort of endpoint which is included in both intervals. So we'll always, when we use this test, you almost always, or do always, just talk about the open intervals. So we're not going to worry about those points. Even if the question doesn't state that it has to be an open interval, it's just going to kind of be assumed. So when we use this test, we only use it to figure out the largest open interval where it's increasing or decreasing. Okay, so we'll go through an example here where we actually use this test. So this test will be used to figure out your intervals of increase and decrease for a given function. So when you're doing this test, the first step is always find the first derivative. So the first derivative of this function f would be x squared minus 4x minus 5. You want to figure out where this function, this derivative function, is positive and negative. So in order to do that, you have to first figure out where it's equal to 0. So you'll set f prime at x equal to 0. And then if it's a quadratic, you would factor. So that's x minus 5, x plus 1. So x equals 5 and x equals -1 are the zeros or roots of the first derivative. So we want to figure out where this is positive and negative. So if you remember back to advanced functions, this is a linear inequality. So there's two ways to do this. You can do this using a table or a graph. A table is probably the way you're going to use it more generally for any type of function. So I'll show you how to use the table. So the table we're going to, so an interval table sometimes you would have called this. Along the top, you're going to start at minus infinity. You're going to break the real number line up at the root. So starting at minus infinity, going to the lowest root, which is -1, -1 to the next root, which is 5, and 5 to infinity. Along the side here, you're going to list the factors. So the factors were x minus 5 and x plus 1. So now inside the table, you're going to figure out which of these, what sign these factors would be on the interval. So from minus infinity to -1, pick a number in that interval. It could be any number, so let's say -10. If you were to sub it into this factor, you would get a negative number. Right? -10 minus 5 is a negative number. If you were to sub it into this factor, you would also get a negative number. So both factors would be negative in this interval. If you're between -1 and 5, so 0 would be a good number to pick. If you pick 0, this factor would be negative, and this factor would be positive. And then if you picked a number bigger than 5, so like 10, subbed it in there, that factor would be positive, and this factor would be positive as well. So now you're going to look at what that tells you about the first derivative. So the first derivative is just the product of these two factors. So it's this factor times this factor. So if you multiply two negatives, that will result in a positive number. If you multiply a negative and a positive, that will result in a negative number. And if you multiply two positives, you get a positive number. So what that means, by the first derivative test, this function is increasing here, decreasing here, and increasing here. So that's your intervals of increase and decrease. So therefore, the intervals of increase are x is an element from, so the ones that are positive, so minus infinity to -1, or 5 to infinity. And then the intervals and intervals of decrease just say interval because it's just the one interval for decreasing. So this one would be the one where it's negative, so -1 to 5. So that's how you use a table. You can also solve the inequality using a graph. So let's just take it over here. So we could graph that derivative function. So the derivative function f prime at x was equal to x minus 5 and x plus 1. So if I were to sketch a graph of this, so this is a graph of the first derivative, and by sketch I mean a very rough sketch. You don't even need like a scale really. I just need the intercepts, which we figured out were -1 and 5, and then it's a parabola opening up, so it would look like this. So I just want to know where is this function positive and where is it negative. So it's positive whenever the graph is above the x-axis. So f prime at x is positive if x is less than -1, or bigger than 5. So you're just looking at the graph where it's above the x-axis and where it's below the x-axis. And f prime at x is negative if it's below the x-axis, which is here. So that's between -1 and 5. So if x is between -1 and 5. So that's your intervals. So that would correspond to your intervals of increase and decrease, right? So you take this right here, and combine it with, and this would be a concluding statement from the other part. Okay, so if you do the graph, if you do this graph, you don't need to do this table. If you do the table, you don't need the graph. So whichever method you want to use is fine. But the table will sort of generalize to more types of functions. The advantage to the table is you don't have to know how to graph the function. If it's just a quadratic, a graph's not that hard because it's easy to graph a quadratic. But if it was a more complicated function, you might not know how to graph it, but you could still always do the table.